I'm Anil Kumar. Welcome to my series on calculus. We'll actually discuss a complete test paper on the first chapter, which is limits and rate of change. We have 6 questions here. Answering these questions, you will gain confidence about basic understanding. Question number 1 here is true or false. Justify your answer. When you rationalize the numerator of square root x plus h minus x over x, the answer is h over x times within bracket square root x plus h plus x. B. The function f of x equals to 2x plus 3 when x is not equal to 4 and equals to 12 when x equals to 4 is not continuous. C. The limit as x approaches 2 of f of x equals to 1 over x minus 2 exists. D. For the function y equals to f of x, where f of 3 equals to 2, with limit of 3 as x approaches 2, there is no removable point of discontinuity. E is, if limit of f of x as x approaches 7 equals to minus 4, then limit as x approaches 7 for f of x whole cube minus 8 times f of x divided by f of x plus 2 is 16. Question number 2 here is geometric representation of our difference quotient expression. Question number 2 is explain how the following expressions are related if s is a position function. S7 minus S of 4 divided by 3, and B is limit h approaches 0 for S of 7 plus h minus S of 7 over h. Question number 3. Given f of x equals to square root of 2x minus 5, determine the slope of the tangent at p equals to 3, 1. Question 4. As water drains out of a 2250 liter hot tub, the amount of water remaining in the tub is represented by the function v of t equals to 0.5 times 150 minus t whole square, where v is the volume of water in liters remaining in the tub and t is time in minutes, where t is between 0 to 150 minutes. Determine the average rate of change of volume of water during the last 20 minutes. Question 5. If a, b is any point on the graph of y equals to 1 over x, where x is greater than 0, find the area of triangle formed by the tangent through AB and the coordinate axis. Question number 6 is, a circular oil slick on the ocean spreads outwards. Find the approximate rate of change in area of the oil slick with respect to its radius when the area is 100 pi meters square. So these 6 questions will help you really understand all the concepts, and I hope you find them interesting and useful. Now let's see how to solve them one by one. Question number 1. It is a true or false, but we need to justify our answer. When you rationalize the numerator of square root x plus h minus x over x, the answer is this. Let's figure it out. Rationalization means you multiply and divide by the conjugate, right? We need to rationalize numerator, so we'll multiply and divide by the conjugate of numerator, which is square root of x plus h plus x divided by square root of x plus h plus x. Now when you do so, you get difference of squares in the numerator, so you get x plus h minus x square in the numerator divided by x times square root of x plus h plus x. Now if you compare, it is not the same. Perfect. A is x minus x square. So this statement is false. Next. The function f of x equals to is a piecewise function. At x equals to 4, the value is 12, But when it is not 4, it is a linear function, 2x plus 3. Is it continuous or not? That we need to figure out. So why don't we just substitute 4 here and figure out whether the first part of the leg is 4 or not at x equals to, is 12 or not at x equals to 4. So what we should do here is we should substitute 4 for x. So we'll write 2 times 4 plus 3. 2 times 4 is 8. So we get 8 plus 3, which is 11. And since it is not equal to 12, it is discontinuous, right? So that's the whole idea. So the idea here is, if you sketch this particular function, what you really get is, at 4, you get a hole, right? But the value of the function at 4 is not 11, it is 12. So you see there is a jump discontinuity, right? So the function is not continuous is true, correct? So this statement is true. There is a jump discontinuity here, or rather there's a hole in the function, right? Okay. Part C is the limit as x approaches 2 for f of x equals to 1 over square root of x minus 2 exists. The answer is false. Can you tell me why? Well, this function is only valid for x which is greater than 2, right? So the limit of the function when x approaches 2 from the left side, right, is not defined. So one side limit exists, which is from the right side, but the limit does not exist at 2 since the limit from the left side is not defined. Is that clear to you, right? So that is how we are going to answer this particular question. Part D and E, let's take it on a fresh page. D is, for the function y equals to f of x, where f of 3 is 2, with limit of 3 as x approaches 2. What they're trying to say is that limit when x approaches 2 for the given function is 3, right? This is what is given here. The second statement, this is the second statement. The very first one is, for the function y equals to f of x, where f of 3 is 2, that means that the point is at 3 the value is 2. Do you see that? It is not saying at 2 the value is 3. You get the idea, right? So now, there is no removable point of discontinuity, right? That is what the question is. What do you think the answer is? Well, this is very similar to what we had earlier. There could be any function. So now we are saying that when you are approaching 2, let's say we have a function, right? So when you are approaching 2, that is, if this point is x equals to 2, then in that case, the y value is 3. But we are given that at 3, the value is 2. So, but we are given that there exists a point at 3, somewhere here, which is 2, right? So that means function must have dropped, right? Something like this. So at 3, sometime later, there is a point here at 3 which is 2, right? We are given this point. We are not given that point. Now if you look at it, it says there is no removable point of discontinuity. Well, when we say limit exists, then from left side and the right side, we are approaching a value which is 3. We could have a hole. You get the idea, right? So the statement is false. Since there is a possibility, of a hole at x equals to 2. Is that clear to you, right? Now, to make this true, we could have had f of 2 equals to 3, right? So then it was continuous function. You get the idea, right? So if this condition was not this, but if it was, if f of 2 equals to 3, then it is continuous. Do you understand? Perfect. That is what it is. E. If limit of f of x when x approaches 7 is minus 4, then limit of this expression is 16. Let's figure this out. So basically, we are given that the limit is minus 4, so we can substitute minus 4 here, right? Applying the rules of limit, properties of limit. So limit of this minus limit of this, everywhere. Limit of, you write this as limit of f of x whole cube as x approaches 7 minus 8 times limit x approaches 7 for f of x, right? Divided by limit x approaches 7 for f of x plus 2, right? Now this limit is given to us as minus 4. So we get minus 4 whole cube minus 8 times minus 4 over minus 4 plus 2. Minus 4 whole cube is minus 64, right? 4 times 4 is 16 times 4 is minus 64. And 8 times minus 4 will give us plus 32, right? Divided by, this is minus 2. So that gives you minus 32 divided by minus 2, which is indeed equals to 16. So therefore, this is true. Now let us try to understand solution of question number 2 on a fresh page. Explain how the following expressions are related if S is a position function. S of 7 minus S of 4 divided by 3 and limit h approaches 0 for S of 7 plus h minus S of 7 over h. So let me sketch a graph. We'll just make some rough sketch here. So let's say we have a function which is kind of like this. Right. We are considering 2 points when we say S of 7 is the value of the function at 7, right? Let's say this point here is this is 7. So S of 7 is this value, right? S of 7. Now when we say S of 4, so let's say 4 is here somewhere, okay. So this point here will be S of 4, clear? Now as you can see here, the difference between these two values, 7 minus 4, is equal to 3, right? So that is delta x. Now when we are saying S of 7 minus S of 4, that is this place, S of 7 minus S of 4, we are talking about delta y, right? Which is this much. And that is delta x. Correct? So this particular expression represents what? It basically represents delta y over delta x. Correct? Change in rise over run. And that is representation of slope of the secant. Right? So slope of the secant line, which is, let me sketch one here now, joining these 2 points. So that's the right triangle kind of for us, right? So this secant. So this slope is what is being represented by S of 7 minus S of 4 over 3. Is that clear to you? Correct? So the expression shown in A is slope of secant. Now, if I take a point which is very close to 7, so if I move this point very close to 7, then what we get here is another point which is, let's say, h away, right? So we are saying S plus h, it could be on the right side of this. Then that will represent the slope of a tangent at this point. So the expression here represents slope of a tangent line at x equals to 7. Do you see that? So in the first case, it is slope of secant line, which is from x equals to 4 to x equals to 7. And here we have a slope of secant line at x equals to 7. So this slope gives you approximate rate of change, right? So this also represents rate of change at x equals to 7 in this particular example. So I hope this part is absolutely clear. Now this is very useful since we are going to use the concept which you have learned in example 2 to answer most of our questions on rate of change. So 3 to 6, all these questions are basically related to this particular concept. Perfect. Now let's take them one by one. Here is question number 3. Given f of x equals to square root 2x minus 5, determine the slope of tangent at a point P, which is 3, 1, right? So we understand now that slope of tangent, basically, let's say m, is equals to limit h approaches 0, f of x plus h minus f of x over h. Correct? In our case, we are given the function f of x as 2x minus 5. The point here is 3, 1, right? You will notice that if I substitute here 3, what do I get? I get 2 times 3 minus 5, which is square root of 6 minus 5, which is equal to 1, right? So that is correct. Is it clear to you? So let's use this equation and find the slope of tangent line. So slope of tangent line m is basically equal to limit h approaches 0. Now this function we want to do at x equals to 3, right? So we are interested in the point where x is 3. Right? So we'll substitute x3 here for x plus h, right? So we get this as equal to square root of 2 times, now x is replaced by 3 plus h, right? So first let's write down a general expression, x plus h, and then we'll replace it with 3. That'll be better, right? So we can write this as x plus h minus 5 square root minus square root of 2x minus 5 over h. So I have not yet substituted this point. Now we'll substitute p 3, 1 in our equation, right? So we can write this as limit h approaches 0 square root of 2 times 3 plus h minus 5 minus, this value is 1 given to you. At 3 it is 1 over h. Is that clear to you? Let's open the bracket and simplify. So we get limit h approaches 0 square root of, this is 6 plus h minus 5 minus 1 over h, which is limit h approaches 0, sorry, 2h. So you have to multiply with 2 both of them, right? So we get here square root of 1 plus 2h. Correct? 6 minus 5 is 1 minus 1 over h. Now we need to rationalize to get the limit. So we get limit h approaches 0. We have square root of 1 plus 2h minus 1 over h. We'll multiply and divide by its conjugate, which is square root of 1 plus 2h plus 1 over square root of 1 plus 2h plus 1, correct? So in the numerator, we get difference of squares. So we get 1 plus 2h minus 1 square, right, which is 1. And denominator, we get h times 1 plus 2h square root plus 1, correct? Now, in the numerator, 1 minus 1 is 0. So we get 2h over we're at limit h approaches 0, square root of, well, h times square root of 1 plus 2h plus 1, correct? Now, h and h cancel. So what you get here is equal to limit h approaches 0, 2 over square root of 1 plus 2h plus 1. Now when h approaches 0, we can substitute 0 now. So we get 2 over square root of 1 plus 0 plus 1, right? So which is 2 over 1 plus 1, which is 1, correct? So 1 is the slope of the tangent line at a given point for the function. Is that clear to you? So we get our answer that the slope is 1. Is that okay? So that is how we are going to answer this question. Now let's move on and take the next question. I'd like you to pause the video, read the question, answer, and then look into my suggestions. The question here is, as water drains out of a 20 to 50 liter hot tub, the amount of water remaining in the tub is represented by the function which is v of t equals to 0.1 times 150 minus t whole square, where v is the volume of water in liters remaining in the tub and t is the time in minutes from 0 to 150, right? So the time is given to us from 0 to 150 minutes. Determine the average rate of change of volume of water during the last 20 minutes. Now what does it mean? Last 20 minutes means what? That means we're talking about t, which is from 20 minutes less than 50. That is from 130 to 150. Is that clear to you, right? So that is what we need. So we need the average rate of change. So the important thing to understand, second thing is secant slope, average rate of change, right? So we get this average rate of change will be what? Value the function which is v at 150 minus this capacity at 130, volume at 130 divided by 150 minus 130. Clear? So that is what we need to calculate. So let's substitute in this equation t as 150 and 130 to calculate. So we get here 0.1. So when I substitute 150, I get 0, right? 150 minus 150 whole square. And then for 130, we get 0.1. 130, so t is 130. So 150 minus 130 whole square divided by 150 minus 130 is 20. Is that clear to you? Right. So the first expression 150 minus 150 is 0. So we get 0 minus, here we get 20, right? 20 square is 40. So 0.1 times 20 square over 20. Correct? So that is negative, of course, 0.1. So we can cancel one of these 20s, right? So 0.1 times 20, correct? So that is minus 2. And what are going to be the units, right? So when we are saying here, volume is in liters, see? Volume is in liters and this is in minutes, correct? So we have to include our units in the answer. So it is, the answer here will be, it is decreasing, right? So it minus means decreasing. So we are saying decreasing at the rate of 2 liters per minute. Is that clear to you, right? Or you could write here liters per minute. Is that clear to you? Minus 2 liters per minute. So both are correct answers. So that is how you could answer this particular question. Now question number 5 actually is a thinking question, right? So this is a very important question from test point of view. If AB is any point on the graph of y equals to 1 over x where x is greater than 0. Find the area of the triangle formed by the tangent through AB and the coordinate axis. So let's try to understand the situation and then we'll find the solution. So what we have is a graph of 1 over x, which will be kind of like this, right? So that's the graph of 1 over x. We are considering x is greater than 0, right? So let there be any point on this. Let me draw a tangent line. Let's say that is the tangent line, okay. Now we want to find area formed by this tangent and the coordinate axis, right? So that area we are interested in finding out. We have a point here which is AB. Correct? Now, since we are given y equals to 1 over x, then actually if x equals to a, then y equals to 1 over a. That is kind of important, right? So this is key to understand. So therefore, the point P will be a 1 over a for the given function. So basically, we are saying that b is equals to 1 over a. Is that clear to you, right? So keep this in mind while solving this particular question. Now, we need to actually find the intercepts of the tangent line. Once we do that, we can have the area of a right triangle, half base into height. But before that, let's find slope of the line, right? So we need to find slope of tangent. Using first principle, that is our definition of limits, we can find the slope of tangent for this curve, right? So let's call this as M, which will be limit h approaches 0, f of, we can write x plus h minus f of x over h. So we can say M is equals to limit h approaches 0. The function is 1 over x, so we can write this as 1 over x plus h minus 1 over x over h. To solve this, we'll take common denominator and multiply. So we get x minus x plus h over x times x plus h, right, over h. Is that clear to you? Now this could be written as limit h approaches 0, x minus x over h is minus h, right, over, these things come in the denominator, we have x times x, h times x plus h. Now h and h cancel, so we get limit h approaches 0 or 1 over x times x plus h with a negative sign, correct? Since these h cancel. And this is equal to minus of 1 over x squared. So what I did was I got a general expression, right? Now in this general expression, we'll find slope when x equals to a, right? So if I substitute a here, I get minus 1 over a squared, right? So at this particular point P, where x is equal to a, we have slope as minus 1 over a squared. Now the point is basically a and 1 over a, since it's a reciprocal function. So we can now find the equation of tangent. At point P, which is a and 1 over a, right? So equation tangent will be, we'll use this y minus y1 equals to m times x minus x1 when a point is given and slope is given. So in our case, it is y minus, the y value is 1 over a, equals to slope minus 1 over a squared times x minus a, right? So x value is a. So when you cross multiply, you get we could write like this. We get a square y minus a equals to minus x plus a, right? Let's bring it on one side. So we get x plus a square y equals to, we have a here, and when you multiply here plus a, which is 2a, right? So that's what we get. Now, let's find x and y intercepts. So the x-intercept here is, okay, let's do it here. So we get our equation, which is, let me write it in bigger letters, which is x plus a square y equals to 2a. Correct? Now, in this, what is the x-intercept? X-intercept is when y equals to 0. So if y is 0, we have this point which is at x equals to 2a, right? So this is at 2a. The y-intercept will be when x values is 0, right? So if I write x0, I get y equals to 2a over a square, or I get 2 over a, right? So that's the y-intercept. Correct? Now, the area is half base into height. Correct? So, so we know x, and so this is 2 over a. Correct? This is 2 over a here. So the area is equals to half of base, which is 2a, right, times 2 over a. So when you do that, 2 cancel, a cancel, we are left with 2. So area is 2 units square. Is that clear to you? So we get area of 2 units square. So we have our answer that the area is 2 units square. Now this is a very important conclusion, and we could have this in some multiple choice questions at times. So I hope all the steps are absolutely clear. What we did was, we have a point AB. It is good to understand that B actually is 1 over A, because the function is 1 over X, right? So B is 1 over A. The point is A 1 over A. That helps. Now we need to find equation of the tangent line. So first let's find rate of change at any given point AB. We use difference quotient formula to find the rate of change. Then we found the equation of line using y minus y1 equals to m times x minus x1. Then we had the x and y intercepts. Area of the right triangle is half base into height, and that gave us 2 units. Clear? Let's move on and take the last question of this test paper. Question number 6. A circular oil slick on the ocean spreads outwards. So the question number 6 here is, a circular oil slick on the ocean spreads outwards. Find the approximate area of change in the area of oil slick with respect to its radius when the area is 100 pi meters square. Now, so we have a circular oil slick, right? So that means it's like increasing. Do you see that? It's increasing outwards. That's what it means, right? We are given that we need to find the rate of change when the area is 100 pi meters square. So at that time, first you find the radius. So we're given area, which is pi r square is equal to 100 pi. So that gives me r square is 100, or r is equals to square root of 100. So r equals to 10 meters, correct? So now the question is that we want to find instantaneous rate of change when r equals to 10. Do you understand? That is what the question is. So again, we'll use difference quotient method to find this instantaneous rate of change. So we say that the instantaneous rate of change is limit h approaches 0 for the function x, well, in this case it is a function of r, right? So let's write general equation first. Minus f of x over h. That's the general equation. However, we have a function which is radius function, right? So we'll write limit h approaches 0 of a of r plus h minus a of r over h. Correct? So in our case, area is pi r square. So the function a of r is pi r square. Right? So we have this as limit h approaches 0. So pi r square means pi times r plus h whole square minus pi r square over h. Right? So let's find a general function first, and then we can substitute r, right? Or you could also write down straight away r, but I prefer to write general function first. So we'll go for general function. So it'll be pi r square plus 2rh plus h square minus pi r square over h, which is equal to limit h approaches 0. So you find that pi r square and pi r square cancel. So you have 2 pi r h plus h square over h. Now you can take h common, right? So we get this instantaneous rate of change equals to limit h approaches 0. You can take h common. So you get 2 pi r plus h over h. Now h and h cancel. So we get this as limit h approaches 0, 2 pi r, correct? Plus h. Now when h approaches 0, we get this answer as 2 pi r. Is that okay? So what is important to note here is that the rate of change of area is same as circumference, right? Do you see that? So let me make a note here, which is rate of change of area equals to circumference. So this is a very important result when we are talking about a circular thing. Is that okay? Now, of course, what we need here is to find when the area is 100 pi or r is 10. So when r equals to 10, instantaneous rate of change is 2 pi times 10, which is 20 pi, correct? The unit will be, it is meter square, meter per meter, right? So that is the rate of change. So this area is meter square per meter. So with time, do you see that? So area is meter square per meter. So that's our answer. So the answer here is, it will be 20 pi meter square per meter. Is that clear to you, right? So I have derived a general expression. Now you could use this for any given value of radius, right? So that is how we could actually solve such questions. I hope you find it interesting and useful. So this was a great exercise. Let me thank the students who have been sharing their test papers with me. And I hope that really helps you all to understand the concepts. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching, and